All right, so 3.6 deals with compound inequalities. So just like any other compound, a compound is made up of more than one thing. Okay, that's the same case here with inequalities. So what this is it's an inequality that has more than one inequality in it. So you're going to have, essentially you're doing two problems, but you're graphing them on the same graph. So they have restrictions, more restrictions than what you normally have with just one inequality. Okay, so like when we look here, it says write a compound inequality that represents each phrase and then graph the solutions. So just thinking about that, we'll go and do number one. It says all real numbers that are less than -3. So that's one part of it, or greater than or equal to 5. So that's the second part of it. Okay, so there's two parts. So we have all real numbers, we're just going to call it X or whatever letter you would like, less than -3. So I'm going to put less than -3. Okay, that's the first one. Now remember, compound means more than one. Or, so then I'm going to put an or in between. So a lot of these compounds will either have connection with the variable in the middle, or you can always use the word or. No matter what, you can always use the word or. You can just write one, put the word or, write the other one. Okay, so X is less than -3, or it's greater than or equal to -5. So that same X is going to be greater than or equal to 5. So now when I have them both written out, okay, because now I wrote my compound, so two things. All we're going to deal with is just two things for your compound, okay? So I have X is less than -3, or X is greater than or equal to 5. So what we're going to do is we're just going to graph them. So I need to worry about -3, and I need to worry about 5. So I have to make sure that my -3 is the farthest left, 5 is over here. I don't care if you put the numbers in between, it's not necessary, okay? So X is less than 3, so open or close circle at -3, open circle at -3. I think I forgot to say negative, okay? It's less than, so it could be anything less than. It could be -4, it could be -5, okay? So it's pointing to the left. Okay, and remember, if you're using your little, the arrow points the same way as long as your variable is on the left, okay? Or, so now the same graph, you're going to put on the same graph, X is greater than or equal to 5, open or close circle at 5, and if it's greater than, it could be bigger than that. So it could be 6, it could be 7, it could be 100, okay, pointing to the right. So that's the compound inequality. So some of these compound inequalities, they're going to shoot away from each other. Some of them are going to shoot towards each other. Some of them maybe will shoot the same direction. Okay, so whatever it is, then you just have to fill it in accordingly. Okay, so it says the time a cake must bake is between 25 minutes and 30 minutes inclusive. So inclusive, what does inclusive mean? It could include it. So that means it could be equal to. So I have to bake this cake and it's in between 25 and 30. Okay, so I could write this a couple different ways. So I could write it 25 is less than or equal to X is less than or equal to 30, because that time, my X, has to be between 25 and 30. So it could be 25, it could be 26, it could be 27, it could be 28, 29, 30, and then anything in between there, like 29 and a half, 29 and, 3/4, etc. Okay. Now, if you didn't want to write it like that, you could have said, well, we know it has to be bigger than 25 minutes. So I could put X is greater than or equal to 25. Okay, that's the first condition. And then I could put an or. And I know that it has to be less than 30, but it could be equal to 30. So X would have to be less than or equal to 30. Now, if you look at this compared to this, they are exactly the same. Do you see how, for lack of better words, again, your alligator mouth is eating your X here with the 25, eating your X with the 25, okay? X is less than or equal to 30, X is less than or equal to 30. They're exactly the same. So you could write it like this or like this, either one is correct. And then when we're graphing, we need a 25, we need a 30, okay? X is greater than or equal to 25, so close circle, pointing to the right. Remember, we talked about this. It could be 26, it could be 27, it could be 28. So when they face each other, you have to kind of be aware of that. And then it's less than or equal to 30. So it's anything in between the two. Okay. So it stops. It can't be 24, so we don't make that arrow go past that. So we just connect the two. Okay, so when we come down and we're actually like solving it without word problems, sometimes they're going to be written like this, and sometimes they're going to be written like this. Either way, we still do our normal. So like if I want K by itself, I see a -2 there. What's the opposite of -2? Add 2. And so just like when you're doing regular equalities or inequalities, whatever you do to one side, you have to do the other. Well, in this case, there's 2 other sides. So if I add 2 here, I have to add 2 here and add 2 here. I have to make it consistent. Okay, so now that's gone. 5 plus 2 is 7. So I have less than K, less than 13, 12, 11, 12, 13. Yep. Okay, now I'm going to graph that. So I needed a 7, I need a 13. Okay, break it down if you need to. If they're both less than symbols, you'll kind of see a pattern of how it's going to shade. But if you need to break it down, break it down. That's saying 7 is less than K. Or you could say K is greater than 7. So open circle at 7. It has to be bigger than it because I'm eating it. K is bigger. So I'm going to point to the right. Okay, and then the sentence says K is less than 13. Open circle at 13. Less than is to the left. So we're going to connect those two up. Okay, so, and remember, same rules apply. So if you're dividing by a negative or multiplying by a negative, you still need to flip your sign. Okay, that hasn't changed. So that's how you do that type. Now I'm going to show you how to do the OR type. Okay. When they're written as OR, in my opinion, it's actually kind of easier because I just kind of put like a little squiggle through the OR and I solve my one, then I solve my other, and then when I graph it, I put it together because that's the compound part. So I have 6b minus 1 is less than or equal to 41. Got to add that 1. That's gone. I have 6b is less than or equal to 42. How do I get rid of that 6 in front of the b? You have to divide that 6 out. Okay, so I have b is less than or equal to 7. Okay, now I'm going to go solve the other side. How do I get rid of that plus 1? Minus 1. So I have 2b greater than or equal to 10. How do I get rid of the 2? Divide. So I have b is greater than or equal to 5. Now when I'm graphing, they have to be on the same graph. I'm going to put it over here. Okay, look at your two numbers. I have a 5 and a 7. So make sure that you put them in order from least to greatest, from left to right, okay? So my 5 is going to come first, then my 7. Okay, now I'm going to break it down. B is less than or equal to 7. So open or closed? It's closed because it has that equal to on it. Sorry for the glare. Okay, B is less than that. That's to the left, and anything smaller than it. So I'm just going to put a little, I know I'm going that direction. We'll see what it ends up happening. Okay, this one says B is greater than or equal to 5. So close circle at 5. Greater than goes to the right. So we're going to connect it up. Excuse me. So with the ORs, just solve one side, solve the other, see what happens. Okay, so sometimes they'll connect, sometimes they'll actually be pointing the same direction, and sometimes they'll be pointing opposite directions. Okay. On number 11, you can't do this problem. So you need to get rid of number 11. There was a typo. So go ahead and get rid of number 11. So on 3 through 12, you're solving and graphing. Okay. On the back, graph the interval. So these are actually easier because there's nothing to solve because they already have it solved for you. So you just have to graph. 17, 18, 19, and 20 is the opposite of what you just did. So they gave you the compound inequality, you solved it and graphed it. Now they're giving you the graph and you have to tell them what it is. Okay, so you have to make your compound inequality. Remember I said you can always put an or in between and then be done with it. So let's just try like 18. So I have an x here. I'm going to use x because that's just a good variable to use. I have a -4. So just like on our other worksheet, I'm going to leave that space in between. Now I'm going to try to go figure out my sign. So it's an open circle, so I know it either has to be a less than or a greater than. Okay, not with the equal to, not with the line underneath. And it's going to the left, so it's actually less than. So x is less than -4. Or, now remember, put the or sign in. Now take care of the other half of your graph. So I have an x and I have a 2. It's a closed circle, so I need that equal to underneath it. Now I got to decide, is this less than or is it greater than? It's greater than 2. It's going past 2. So it could be 3, it could be 4, it could be 5. So greater than or equal to, because it is closed, 2. And that is how you rate your compound inequality. Don't get confused with 17. Just take a look and go, okay, do that one. No, do that one. Okay, don't get confused just because they're sharing the same number. Okay, then you have 2 more right there. And then 21 and 22, you're just solving. You don't actually have to graph. Okay, so solve, don't graph. That's how you do 3, 6. Now, you're also, the next day, you're going to be assigned lesson quiz 3, 3, and 3, 4. Okay, and you're still going to be working on 3. You should be able to finish 3, 6 today, right away. And then tomorrow, you'll be working on lesson quiz 3, 3, and 3, 4, or the next day, however that works out in your blue gold schedule. And then on the asynchronous day, we're going to be working on a worksheet that's called Utterbunk. Let me find it here for you. Okay, so this is what Utterbunk looks like. Okay, and it's just one-sided, and what you're going to have to do is you're going to have to just do it on a regular piece of paper, and you're going to attach that into your assignment, and that will be how you get graded for this. So again, the good news is with these kinds of worksheets, it kind of self-corrects. Yeah, you have to show all your work, but if the thing at the bottom, the riddle, doesn't make sense, then you did something wrong. Go back and figure it out. So again, you're just solving. You don't actually have to graph these. So if I want to get all my x's to one side, I'm going to subtract that 3x over. Okay, that leaves me with 2x plus 2 greater than 10. And remember, your same rules apply. If you divide or multiply by a negative number, you need to flip that sign. I have not done that. I have only subtracted so far. Now I want to get x by itself. I'll subtract that 2. So I have 2x greater than 8. Okay, how do I get rid of that 2? Divide by 2. X is greater than 4. So look for x is greater than 4. I see it right here. So number 1 is R. Wherever you see a 1 down here, you're going to put in an R. That's how you do this worksheet. So you're just solving. And remember that if you divide or multiply by a negative number, you need to flip your sign. So that should take care of your instruction for those two.